Hello, everyone. So we're back again. It's Mr. G, and we've done the mass movement part of our packet for weathering and erosion, and we've completed the 19 questions that were at the end of it. Okay. So and you should have gotten your grade back by now. Okay. So then we're going to move on to the next part of this packet, and we're going to use a page in our reference table, but I've supplied you the page here, right, in your packet, so you don't really need to take the page out of your reference table. And this chart here, what this chart says is it's the relationship of transported particle size to water velocity. Okay, well, what does that mean? Basically, it's really simple. Basically means this. Hey, how big a particle or weathered rock can move based on how fast the water is moving, right? Faster moving water, you can assume, can move larger pieces, right? And slower moving water can't move the large pieces, but it can move smaller pieces, right? Because it's slower moving water. This chart on the reference table here tells us how fast the stream or the river or the water has to move a certain size particle. Okay. So let's take a look here. I already shaded in some gray lines here just to give you an example. So we're going to zoom in. All right. Let's zoom in here. Oops, that was a mistake. Let's do like this. There we are. So let's take a look here. All right. If you have your reference table at home, you could follow along in the reference table on paper if you'd like. If not, just watch the screen. Okay. So let's look at the different things that this chart tells us. Over here, to the left, it's particle size. How big the particle is. Okay, how big the particle is. All right. On the right side, it's the name of the particle. Okay, so we have clay, silt, sand, pebbles, cobbles, and boulders. Okay. On the left side, it's 0.0001 centimeter in diameter, the size, right? The size, which is really, really tiny. And there you have 0.001, a little bit bigger, 0.01, 0.1, 1, 10, and 100 centimeters in diameter, right? So you can notice that the particle size gets larger as we go up, and up the chart. So that means that these over here get larger as we go up and up the chart. Clay particles down at the bottom, okay, those are the smallest. Tiny, tiny, tiny pieces. Almost microscopic, not quite, but very, very tiny. Then we have silt, which is a little bit bigger. Then sand. I think we're all familiar with sand, right? We've been to the beach before. Pebbles, right? A little larger pieces, right? Pebbles, not Fred Flintstone's daughter Pebbles, no. And we're not talking about the cereal fruity Pebbles. No, this is different. These are the rocks called pebbles. Right? Then we have cobbles, a little bit bigger, and then finally boulders. Boulders are big rocks that can range from something like this big all the way up to the size of a car. Really, really big rocks. Okay. Down at the bottom here, this tells us how fast the stream is going. Okay, 0.01 centimeters per second, that is the slowest, all the way up to 1,000 centimeters per second. That's the fastest. Okay, let's stop a second. Smallest, largest. Clay is the smallest, boulders are the largest. Slowest, fastest. 0.01, slowest stream velocity. 1,000 centimeters per second, fastest stream velocity. Okay, so how do we read this chart? I put in these little gray lines here for an example for you. Okay, so let's just take a look at this number here, 1. Right, that's 1 centimeter per second. If you follow 1 centimeter per second and go straight up, it touches the velocity line, right? That's that solid black line. It touches the velocity line here. Well, how big a particle can 1 centimeter per second, water moving at 1 centimeter per second, how big a particle can it move? Well, it can move a particle that is, well, if this is 0.01 and that's 0.1, that means that each one of these is worth 0.01 in value. For example, this is 0.01, 0.02, 0.03, 0.04, 0.05, and so on. Okay? So 1 centimeter per second can, that's water moving, can move a particle size that is 0.02 centimeters in diameter, in size. Okay, one more time. A stream flowing at 1 centimeter per second can move a rock particle the size of 0.02 centimeters. Okay? What kind of rock is 0.2 centimeters? Well, that's sand. Anything that is in the size range of 0.006 to 0.2 is considered sand. Another example is anything that's from 0.2 centimeters in diameter all the way up to 6.4 centimeters in diameter. Well, those are considered pebbles. Okay? All right. Let's try another example here. How about 10 centimeters per second? How fast can how big a particle can water moving at 10 centimeters per second? How big a particle can it move? Well, let's see. If we go up 10 centimeters per second, that's right here. We go straight up. Hits the velocity line right there. It looks to be right about at that dotted line. Right there. Okay, well, what size is that? Well, if that's 0.1 right here, this must be 0.2, right? And then that would be 0.3, 0.4, 0.5, and so on. So at 10 centimeters per second, the stream can move a particle 0.2 centimeters in diameter. Well, what kind of particle is that? Well, let's see. It's right there on the border. It's somewhere between pebbles and sand, right? It's a very large particle of sand, right? The largest particle of sand, or it could be the smallest pebble particle, right? Because it's right on the border, all right? So that's how we read this chart. Let's try one more. How about 100 centimeters per second? How fast can 100 centimeters per second? How large a particle can 100 centimeters per second move? Well, we go up 100 centimeters per second. Boom, hits the line right there. We go straight across. Okay. Well, if this is 1.0, then this is 2.0, and this is 3.0. So it can move a rock particle 3.0 centimeters in diameter if the stream flow is flowing at 100 centimeters per second. Okay. What kind of rock particle is 2.0 centimeters in diameter? Well, let's see. 2.0 is here. I'm sorry, 3.0. That's what we were talking about. Okay. Oh, well, that's within the pebbles range. Okay. So that's how we read this chart. Why don't we do the first question together? Let's go up to the next page. All right, here we are. It says here, base your answers to the following question on the cross-section and the data table below, and on your knowledge of earth science. The cross-section shows the profile of a stream. What did I say profile was? Side view, right? Profile of a stream that is flowing down a valley from its source. Points A through E represent locations in the stream. The data table shows the average stream velocity. Right, we know that that's from the chart, at each location. The velocity of water in the stream remains the same at all locations. Okay, so the stream is going to be the same at all locations. It says here, what is the largest type of sediment that could be transported at location B? Okay, well, we see here location B is way up here. Well, it gives us elevation. It gives us distance from the source. How can we tell what the particle size would be? Don't know. But wait a minute. We have a chart down here. This has some other information we can use. Let's take a look at that. So it says, what's the largest type of sediment that can be transported at location B? Well, location B here is 110 centimeters per second. 110 centimeters per second. Let's see. Let's zoom in case you can't see that. Right? Whoops. Too far. There we go. 110 centimeters per second. Okay. Well, let's take a look at our reference table page. Here we are. 110 centimeters per second. Well, if this is 100, and that's 500, and that's 1,000, right? Then this must be 100, 110, 100, 200, 300, 400, 500, right? So each one's worth 500. This is saying 110. Okay. Well, 110 would be like right about here. Okay. Right next to 100. It's almost 100, right? 110. So let's see if we go straight up and it touches it right about there. We know that it's pebbles that it can move, right? And what size particle are we looking at? Just like the example I gave before, right? 3.0 centimeters in diameter. Let's see if that's a choice, one of the answers. Well, pebbles is the answer there. We checked here, at 110, it can move pebbles. Therefore, the answer is C, pebbles. Okay? So that's how we do these questions using this chart. All right? I hope this helped. Email me if you have any questions. Okay? And we'll talk soon. Bye.